So hi everyone, welcome back. So here we're going to discuss the next problem in a program evaluation review technique. So here it shows the problem for your reference. A small project is composed of 7 activities as given below. Here it's an activity, the 3 different times. While talking about the PERT, it having a 3 different times, that is optimistic time, most likely time and pessimistic time. The following activities are 1 to 2, 1 to 3, 1 to 4, 2 to 5, 3 to 5, 4 to 6 and 5 to 6. So respected activity having a 3 different times, just I mentioned here. And with the help of this above information, we need to be find out 6 parameters. Okay, the first one is draw a PERT network, and second one is find expected duration, standard deviation and variance of all activities, and third one is what is the expected project length, and fourth one is calculate the variance and standard deviation of the project duration, and fifth one is what is the probability that the project will be completed at. In this subdivision you need to be find out 3 different variations. One is expected duration, 3 weeks earlier than expected duration and 3 weeks later than expected duration. So these are the 3 different things. I think you people know this meaning as very well. And last one is what is the project duration when you are 95% sure that the project will be completed in time. So it's not indicating 100%. So here they mentioning as 95% of sure to complete the project within the time. Okay, so now we see the problem. So as I already mentioned, there will be 2 different formulas there. So one is TE. So we need to be find out a single duration. Okay, with the help of 3 different duration. The formula once again I repeat for your reference is T0 plus 4Tm plus Tp by 6. This is a formula to calculate TE of single estimate duration. And next one is variance of each activity, that is sigma square equal to Tp minus T0 by the 6 the whole square. So this is one of the formula I mentioned earlier for your reference. Okay, so this is the activity T0, Tm, Tp and Te and sigma square. You need to be find out these things. Okay, so by substituting this T0, Tm, Tp in T0 plus 4Tm plus Tp by 6 the formula, you will get the Te for the activity 1 to 2 is 2, 1 to 3 is 4 and 1 to 4 is 3, 2 to 5 is 1, 3 to 5 is 6, 4 to 6 is 5 and 5 to 6 is 7. So similarly with the help of Tp minus T0 by 6 the whole square, you will get an variance thing, that is a variance here with the help of this Tp and T0. Okay, by substituting these 2 values in the above mentioned formula, you will get the sigma square value for the activities for 1 to 2 1, 1 to 3 1 and 1 to 4 1, 2 to 5 is 0, 3 to 5 is 4 and 4 to 6 as 1 and 5 to 6 as 4. Okay, so this is the tabular column we need to be do initially. And first thing we need to be find out is draw a PERT network. That is the first statement here. We need to draw a network. You people know how to draw a network. So 1 to 2, 1 to 3, 1 to 4. So single event, event 1, from that event 1, the 3 activity need to be start. That is 1 to 2, 1 to 3 and 1 to 4. So 2 to 5, from that event 2, the 5th activity need to be start, the 5th one, and again 3rd, 5th one need to be joined here, and 4th one, the 6th activity need to be started. And 5th activity, the 5 ends with an activity 6. So with this network, we can easily identify that it should having a single start and a single end event. Okay, so this is a draw a PERT network. This is the first subdivision is over. So next one, find expected duration, standard deviation and variance of all activities. Okay, so that is the statement we find out here, expected durations and standard deviation here. So with the help of this particular network, we need to be identify what are the possible paths. Okay, so this is the possible path. The possible path in the sense 1 2 5 6, 1 3 5 6 and 1 4 6. So these are the 3 different possible paths there. Okay, so I repeat once again, the possible paths 1 2 5 6, 1 3 5 6 and 1 4 6. So these are the possible paths. So you need to be add the TE value. Okay, that is duration value of each path you will get. For 1256 you will get 10 weeks, 1356 you will get 17 weeks, and 146 you will get 8 weeks. We know the expected project length is 17 weeks because this is the maximum duration occurred, and this path is called as in critical path. Okay, so after find out the critical path, we need to be draw the another line in that path. Okay, so now we find out that the critical path is 1356 and the critical duration is 17 weeks. Okay, so after that, the second one they mentioned as standard deviation variance of all activities need to be find out. We already crossed. And what is the expected project length? So this we need to be find out with the help of sigma, that is variance formula, standard deviation. So sigma is normally called as a standard deviation and sigma square is called as a variance. Okay, so variance, we know that 1 plus 4 plus 4 equal to 9 weeks. How this 1 plus 4 plus 4 find out means the only critical path activities, we need to be take the values of only the critical path activities. So here the critical path is 1 to 3, 3 to 5 and 5 to 6. Here what's the variance value for this particular path? For 1 to 3 the variance is 1. For 3 to 5 the variance is 4. For 5 to 6 the variance is 4. Okay, so that's why 1 plus 4 plus 4 here mentioned as 1 plus 4 plus 4, which is equal to 9 weeks, and standard deviation we know that root of variance is equal to 3 weeks. Okay, and you having one different formula there here. So because of need to be find out the probability, so we need to be take this particular formula. Normal derivative factor for scheduled completion time is that equal to x minus mu t divided by sigma t. So this is the formula. So x intercepts the scheduled completion time, and mu t is expected duration of the project, and sigma t is the standard deviation of the project. So this is the initial thing we need to be analyzed and identified. So before step up into the next subdivision, that is a probability determination. So until this you people understand clearly. So now we go to the next subdivision of fifth one. What is the probability that the project will be completed at? Expected duration. So expected duration means, so this is the final duration, that should be 17 weeks. So what is the probability of getting this particular project completed with that exactly of 17 weeks? Okay, so the normal deviation takes place for the completion of project. So this is the formula. Here x equal to 17. Here x equal to the for subdivision, x equal to 17 and mu t is also 17. So because expected duration, first subdivision they ask expected duration, our duration is 17 weeks. So 17 minus 17 minus 17 divided by sigma t is also, because 0 by sigma t equal to 0. So z equal to 0. So here you having one table. This is called as a normal distribution function table. Okay, so in examination point of view, we will give this particular table for your reference. Okay, so here we will find out that z equal to 0. Okay, you need to be marked for z equal to 0. What is the probability percentage is 50. Okay, so for this particular first subdivision, the probability of completing with the expected duration of the project is 50%. Okay, so next one, normal derivative factors for completion of the project 3 weeks earlier. 3 weeks earlier means, so here expected duration is 17, 3 weeks earlier, 17 minus 3, we get an 14. That is called as x. X equal to 17 minus 3, which is equal to 14. So substitute this 14 in this formula. 14 minus this mu t is 17. 17 divided by sigma is 3. So because sigma is, we find out the sigma equal to 3. 3 substituting, you will get an value of minus 1. Okay, minus 3 divided by 3 minus 1 is that here is that equal to minus 1. So by in the stand mean, okay, in the normal distributive function for the value minus 1, what is the percentage? 15.9 is the probability percentage. Okay, so this is the probability percentage 15.9, but here it mentioned 15.87, but in most of the books the point is not an issue. Okay, and next one, third one, should be completed 3 weeks later. Okay, so 3 weeks later means we know that expected duration is 17 weeks. 3 weeks later, 17 plus 3, we have So we know that 17 plus 3 equal to 20. So here z equal to 20 and mu t equal to 17. So 20 minus 17 divided by 3, you will get one answer. Okay, so for z equal to 1, you need to be find out the probability value in that in the table. Okay, so this is the table. In the table for 1 z equal to 1, so what is the percentage is 84.1. Okay, so this is mentioned here, 84.1. And next one is, what is the project duration when z for 95%? For completion of the project with the expected of 95%, what is that value we need to be, what is the number of weeks required? Okay, so that we need to be find out with the help of that tabular column. So z 95% for 95%, so where it comes 95%, 95.5 and 4.5, between 1.7 to 1.6. Okay, so with the help of this standard thing, we exactly take as the value of 1.647 for the z. Okay, the probability factor. Okay, 1.647 is the z, x minus 17 divided by 3, so we will get x equal to 21.94 weeks. So from that we can easily identify that for the completion of 95% of thing, it requires 21.94 weeks of time. Okay, so that's all from that PERT problem. So if you have any questions need to be asked, just type it the message in comment box. Okay, so thank you.